In this second video on polynomial equations, we'll begin to look at operations on polynomials. So, I mean, just like we deal with numbers, right? We add numbers, we subtract numbers, we divide numbers, we multiply numbers, and do all sorts. We take square roots, we take powers of numbers and everything. So let's see what we can do with polynomials, right? Polynomials are basically algebraic expressions like we saw in the last video. So in this video, we'll be looking at operations on polynomials like addition and subtraction, multiplication using different methods like the FOIL method, the box method, general expansion, and all that. Then we'll look at special expansions like the binomial theorem and Pascal's triangle. Interestingly, I have a whole playlist on binomial series. So in this case, I'm just going to mention it in passing. So if you're interested in binomial series, so check the playlist for binomial series. You find everything from the nitty-gritty to very advanced forms. Then we talk about polynomial division, which I think I want to emphasize on a lot. Interestingly, I just start in this particular video, I will just start the polynomial division. But in the next video, I'm going to really take a deep dive into it and look at it. So I think it deserves a separate video. So watch out for that. So then, of course, as usual, we'll have some practice problems. So let's go ahead and talk about addition and subtraction of polynomials. So the basic idea here is this. To add or subtract polynomials, write each polynomial in standard form. So write in standard form. Standard form means you have your leading term has got to be the term with the highest exponent, and it goes in descending order like that. Then after doing that, you can group like terms. Okay, so you can same variable part and exponents. So e.g. x squared with x squared. Then add or subtract the coefficients of the like terms. So depending on the signs you have, then only the coefficients will change. So in addition and subtraction, only coefficient change. Powers, the exponents do not change. So only the coefficient change. The variables and exponents stay the same. Okay. So let's see this example for a one variable addition. So you have 3x squared minus 5x plus 2x minus 7 plus 4x cubed plus x squared minus 5x plus 10. So based on what we have said, it means you're going to add 3x cubed plus 4x cubed. That's why you have 3x cubed plus 4x cubed, and that's 7x cubed. And you have minus 5x squared plus x squared. So minus 5x squared plus x squared, that's minus 4x squared. Then 2x plus minus 5x. So you have minus 3x. Then minus 7 plus 10, that gives you 3. So at the end of the day, it simply means that if you do that addition, if you add this together, 3x cubed plus 4x cubed, 7x cubed, minus 5x squared plus x squared, minus 4x squared, 2x minus 5x, that's minus 3x, minus 7 plus 10, that's plus 3. And that's what we have for one variable addition. So let's try one variable subtraction. So in this case now, so you see, what we did here was just that, so we could just go straight. But here you have to be more mindful of the sign. The sign is really important in this situation. Okay. So for one variable subtraction, you have imagine 5x squared minus 3x plus 1 minus 2x squared plus 7x minus 4. Okay. So you can rewrite by distributing the negative sign. So you have 5x squared minus 3x plus 1. So the negative sign can go inside, so you can work more freely with the rest. So if you change this to positive, so all the minus goes inside. So minus 2x squared. This was positive, so it becomes negative. This was positive, 7x, it becomes minus 7x. Minus 4 becomes plus 4. So now you can do what we did before. So 5x squared minus 2x squared, that's 3x squared. Minus 3x minus 7x, that's minus 10x. 1 plus 4, that's 5. And that's why we have this 3x squared minus 10x plus 5 right there. So let's talk about multivariable addition. Okay, so in this case, we have 2x squared y minus 3xy squared plus y, then 5xy squared plus 4x squared y minus 2y. So in this case, now we have to be careful because we now have more than one variable. So here now, you want to be sure that you see this 2x squared y is not the same as this one. So it is 2x squared y will go together with 4x squared y, then minus 3xy squared will go with 5x squared y, then y will go with minus 2y. So in that case now 2x squared y plus 4x squared y, that's 6x squared y. Then minus 3xy squared plus 5xy squared, that is 2xy squared. Then y minus 2y, that's minus y. So the result is simply 6xy squared plus 2xy squared. 6x squared y rather So you can see, you can easily get confused. So you have to be very careful when the variables are more than one. So 2x squared y, I mean 6x squared y plus 2x y squared minus y. That's the answer to this addition. Okay. Having taken care of that, then we go ahead and talk about multiplication of polynomials. So we can have monomial times polynomial. So in this case, we just use the distributive property. So if you have to multiply, so you have a multiplied by b plus c, just say a multiplied by b, then plus a multiplied by c, and that's it. So that's straightforward. So in this case, now you have 3x multiplied by 4x squared minus 5x plus 2. So that is 3x plus 4x squared first of all, then 3x times minus 5x, then 3x times 2. Okay, so 3x plus 4x. So in this case now, in the case of addition, only the coefficients changed. The exponents remain the exponents and the variable remain the same. But in this case, you are going to have the exponent changing because you're multiplying. So 3x raised to power 1 times 4x raised to power 3. That's like 3 times 4 times x times x times x. That's 12x raised to power 3, as we have here. Then 3x times minus 5x. That's 3 times minus 5. That's minus 15, first of all. Then you have x times x. That's x raised to power 2. Then 3x times 2. 2 times 3 is 6. And then you have only one x. You have 6x. So if you do this monomial times polynomial now, so you have 12x cubed minus 5x, 15x squared plus 6x, like this. Okay, so now we can then talk about polynomial times polynomial. So for monomial times, it means you're multiplying a polynomial with just one expression, with just one term. Okay, but polynomial times polynomial. So here, this is monomial times polynomial. So all a is a monomial here, 3x is a monomial here. All right. But what if you have a polynomial multiplied by a polynomial? So in that case, you have for any polynomials, p of x and q of x, you have p of x plus q of x into rx equals, so this rx now. So you have p of x multiplied by rx plus q of x multiplied by rx. So for two binomials in that, like that, you have a plus b into c plus d. So that's a into c. So a will multiply everything first, then plus, you now take the next one. So B will multiply everything again. So you have A multiplied by C. Okay, I think I need to, let me write that out for clarity's sake. So you have A plus B, okay, multiplied by C plus D. So what we are doing here is you take A first. So you have A multiplying C plus D, and then you take plus B multiplying C plus D. So you can now expand. So you have AC plus AD plus BC plus BD. If there's anything common, you can then put them together. So in this case, nothing is really common like that. Okay. So that's why you have AC plus AD plus BC plus BD, just like what we have right here. Okay. So two structured methods. So there are two structured methods for binomials, right? We have the FOIL method for binomial multiplied by binomial, and we have the box method, that's area model useful for larger products. Okay, so for FOIL, now what I just did is the FOIL method, like that, what I did there. So for FOIL means, FOIL stands for first, outer, inner, last. Okay, first, outer, inner, last, where you have just what I did, x plus 3, for x plus 3 times x plus 5 now. So you take x, multiply x by x, then multiply x by 5. So that's first, outer, then inner and last. So first, outer, inner and last. So x times x, x squared, x times 5, 5x, 3 times x, 3x, 3 times 5, 15. And then you can then tidy things up, and you have x squared plus 5x, x squared, 5x plus 3x is 8x. So x squared plus 8x plus 15. So you just add together and you get that result. So FOIL is just a distributive property applied to two binomials, basically. So for the sake of clarity, I'll do it again. X plus 3, x plus 5. So you have x plus 3 multiplied by x plus 5. Again, what we are saying is x multiplied by x plus 5, then plus 3 multiplied by x plus 5. That's what is happening there. So we now have x times x. So we have x times x plus x into 5 plus 3 times x plus 3 times 5. So that is x squared plus 5x plus 3x plus 15. So we can then have x squared plus 8x, because you can add these two together, plus 15. That's what has just happened over there. Okay. So we have the box or area method. Now, this is a very interesting method, and it's particularly good for when you have very long terms. But I mean, it can also get boring, right? It can get boring. So I think I'm just going to go straight. I'll use the box method for x plus 3, x plus 5, and I'll now use it for this big expression to actually make it clear. So you can see the movement, x plus 3, x plus 5, box method. So this is what we have done here is the FOIL method. FOIL method. Okay, so let's go for the box method now. X plus 3, x plus 5 box method. So x plus 3, x plus 5. So because each one has two terms, so we can have x plus 3, right? Then x plus 5. That's what the box method is. So you now say x times x, x squared. X times 5, 5x. And 3 times x, 3x. 3 times 5, 15. So then you now have your result will now be that x plus 3 into x plus 5 is equal to this x squared. So you take it, x squared, and you have 5x, that's 5x, plus 3x, you have 3x, plus 15. So it gives you basically the same thing. But I mean, this one is more visually helpful, right? So you have the usual 8x plus 15. So it's visually more helpful than, the FOIL method. The FOIL method is more, well, it's still simple, but this one you can see what you're doing. I mean, you just choose your method, right? But it helps a little bit more to see what you're doing straight off. So 2x minus 3. Okay, this is 2x minus 3 into x squared plus 4x plus 1. So I want to use the FOIL method for all of that. So let's see how that goes. So I mean, we want to use the box method. So, I mean, okay, I think I'll just go through this, then I'll now do it on that other page. So for the box, or what you call the area method. So you see, area is like length times breadth, and that's exactly the kind of thing I did here now. So you have this, so this is length and breadth, or breadth, length, height and length, or something like that. So that's why you can call it the box or area method. So draw a box with 2 rows and 2 columns. This is for this one now. So 2 rows and 2 columns. Put 2x minus 3 on the left rows, then put x squared 4x on the top columns. 2 rows and 3 columns, because this is 2 rows. So 2 terms, that's 2 rows. 3 terms, that's 3 columns. So, and then put 2x minus 3 on the left rows, put x squared 4x 1 on the top columns, right? Fill each cell by multiplying term by multiplying row term by column term. So you're going to have this kind of expression. So that's 2x multiplied by x cubed, 2x multiplied by x squared, and all that. So I'm going to demonstrate it. That's why I'm just not bothering so much about this right now. So you can now fill each cell by multiplying row by column, okay, like this. Then combine like terms. So once you combine like terms, then you get your answer 2x cubed plus 5x squared minus 10x minus 3. So let's go for that. So exactly what we've done with this now, we do the same. So you have 2x minus 3. So you have this now. 1, 2. So this is 2x minus 3, okay? And this is x squared. This is 4x plus, that's plus 4x. That's so you can skip this sign. But minus, you have to go with the sign. So 2x times. So the reason this is useful is you can easily get confused in the other case, but here you can see everything clearly the way it is. Let me be sure I got my signs right. I have a feeling I might have messed up a sign. Oh, yeah, I think I'm good. Yeah, I think it's fine. Okay, so once you do that now for the box method, so 2x times x squared is 2x cubed. 2x times 4x is 8x squared, right? 2x times 1 is 2x. Then minus 3 times x squared, that's minus 3x squared. Minus 3 times 4x is minus 12x, right? Minus 3 times 1 is minus 3. I hope that's right. 2x times x squared, 2x cubed, right? Then 2x times x times 4x, that's 2 times 2, 8. X times x, that's x in 2 places. Then 2 times 1, 2. Then x. Then minus 3x squared. 3 times 4 is 12. So minus 12x and minus 3. Good. So what we're then going to do is to say that we have 2x minus 3 into x squared plus 4x plus 1, which is equal to, so we have 2x cubed, and then we have 8x squared and minus 3x squared. Those are the two like terms. So 8x squared plus 3x minus 3x squared, that's plus 5x squared. Then we also have minus 12x plus 2x. So minus 12x plus 2x is simply minus 10. So it's like you have you're owing 12, but you have to pay 2, you're still owing 10. So that's minus 10x, then minus 3. And that is the box method, which I think is looks a bit more graphical, if you want to multiply. So you stress your brain less if you use the box or area method like that. All right. So having talked about that, can we then talk about general expansion strategy? So to expand P of X by Q of to expand P of X times Q of X. So first of all, write both polynomials in standard form. So then you multiply each term of P of X by every term of Q of X. It's the same thing we've been doing. Then combine like terms. So you have 2x squared plus x minus 1 into x squared minus 3x plus 4. So multiply term by term. So first of all, 2x squared times x squared, you get 2x raised to the power 4. 2x squared times minus 3x, you have minus 6x raised to the power 3. 2x squared times 4, you have 8x. Then you go take x again. So you take this second x times x squared, x cubed, x times minus 3x, that's minus 3x squared. X times 4, you have 4x. Then you now take minus 1. So minus 1 times x squared, you have minus x squared. Then minus 1, okay, times minus 3x, you have plus 3x. Then minus 1 times 4, you have 4. You have minus 4. Then you can now combine like terms. So, and then you get your result finally, okay? So you can use any of the methods we've used before. So to drive the point home, let me do this still. So you have 2x squared plus x minus 1 into x squared minus 3x plus 4. So let me go over there. Of course, you can expand directly, but I think I want to use the box method still. I think it's sweet. You have 3 terms in each case. So you need to draw a 3x3 box. Okay. Something like this. So you have 2x squared x minus 1. Then you have x squared minus 3x 4 minus 3x and 4. Okay, so you have 2x squared times x squared, that's 2x raised to the power 4. 2x squared times it, that's minus 6x raised to the power 3, right? 2x squared times 2x squared times 4, okay? That is 8x squared. And then you have x times x squared, that's x cubed. X times minus 3, that's minus 3x squared. X times 4 is 4x. Then minus 1 times x squared, that's minus x squared. Minus 1 times minus 3x, that's minus and minus is plus. 3 times 1 is 3. So you have 3x. Minus 1 times 4, that's 4. So now you come to that point where you want to do everything together. So you have 2x squared plus x minus 1 into x squared minus 3x plus 4 equals, so we can go straight. This is 2x raised to the power 4, like that, 2x raised to the power 4. Then for x cubed, now that's the next thing, right? So for x cubed, we have minus 6x cubed plus x cubed, right? So you are owing 6 and you have 1. So if you pay the 1, you still owe 5. So that's minus 5x cubed. So the next thing, you have the x squared. So as you can see, these things always they kind of go together. So for the next one now, you now have this. So that's 8x squared minus 3x squared. That's 5x squared minus x squared. That should be 4x squared. That's plus 4x squared. Then again, you have 3x plus 4x. That is 7x and then 4. Okay. So if you expand that, I think this box thing is pretty easier. So it's visual and you don't have to imagine too much. Okay. Just do your job and go. So 2x raised to the power 4 minus 5x cubed plus 4x squared plus 7x plus 4. That becomes our answer, just like what we have right here. Okay. 2x raised to the power 4 minus 5x cubed. Right. So yeah, minus 5x cubed. 4x squared, 7x, 4. Yeah. 7x. Is it plus or minus 4? Aha. You see, I made a mistake. Okay, that's minus 4. So this is minus 4. Okay. And this is minus 4. So minus 4, like that. Okay. So be careful with the signs. Minus 1 times 4, that's minus 4 right here. Okay. Okay, now that is done, so we have some special expansions. In fact, I think I have a playlist on mental math tricks. So fast ways of of dealing with some maths expressions. All right, so you can find some of these things there. So I'm just going to run over this because I have a playlist on it. So special expansion. So you can have perfect square trinomials. So square of a sum, you have a plus b raised to power 2. So that can easily be a times a squared. Then okay, well, I mean, what do I do? Let me just go. So a plus b. So you have a plus b squared, a plus b squared. That's simply a plus b into a plus b. And that is a times a squared. A times b, ab. B times a is still ba or ab. B times b is b squared. So you can then have a squared plus 2ab plus b squared. So from this kind of standard now, you can then, it means you can do many other things by just following that. So you have x plus 5 raised to power 2 now. You automatically know that will be x raised to power 2 plus 2 times x times 5, then plus 5 raised to power 2. Following this pattern, okay? So the square of the first one plus 2 times the product of the two plus the square of the last one. That's all. And then you just simply have x squared plus 10x plus 25, like that. And that just goes easily, okay? So that's what that is. Then that's the square of a sum. Then what about the square of a difference? Okay, the square of a difference, you have a minus b squared. So that's a minus b all squared. So that's, a minus b into a minus b. So that is a times a squared. A times minus b, that's minus ab. Then minus b times a, that's minus ab again, or minus ba. Then minus b times minus b. Minus and minus is plus, b times b is b squared. So that's a squared minus 2ab plus b squared. So that means that, for what we did before, okay, let me just take any other one. So if you have like y minus 7 raised to power 2, what do? Just say y raised to power 2 minus 2 times y times 7, then plus minus 7 raised to power 2 now. Minus 7 raised to power 2. So you have y squared minus 2 times 7, 14y. Minus 7 times minus 7, that's plus 49. So this can give you a very fast way of dealing with expressions like this. Okay? So imagine you have 3x plus 5 raised to power 2. So you just know that's 3x all squared. That's 9x squared. Then 2 times 3x times 5. That's 2 times 3, 6 times 5, 30x. Then 5 squared, that's 25. So easy, you just go fast like that. Then we also have something like the product of a sum and difference. So these are product conjugates now. So a plus b times a minus b, that's simply a squared minus b squared. How does that come about, right? Maybe you're wondering. So you have a plus b into a minus b. Of course, that's a multiplied by a plus b, then plus b multiplied by a minus b, right? So, oh, sorry, that's my bad there. So a multiplied by a minus b, then plus b multiplied by a minus b again. So that is a times a squared, a times minus b, that's minus ab, b times a is ab or ba, then plus times minus b times b, that's b squared. So ab cancels ab, so you have a squared minus b squared. So since you have seen this pattern, you don't have to keep wasting your time. So anytime you see x plus 7 into x minus 7, you simply just know it is x squared minus 7 squared easily, okay? And that's just x squared minus 49. In the same way, if you see x squared minus, say, 16, that's simply x minus, that's simply x squared minus 4 squared. And once you can do this, that will just be x plus 4 into x minus 4 easily. In fact, it can even get trickier. Imagine you have z squared minus 3. How do you do this? So you can just say this is z squared minus root 3 squared, because root 3 squared is 3. So this will just be z square root of minus root 3 into z plus root 3. It doesn't matter which one comes first. Minus can come first, plus can come first. Anyhow you want to do that. Okay, so these are very fast things you may need to master. So that's why you have 2x plus 7 into 2x minus 7. So you just go straight and you just know it is 2x squared minus 7 squared. That's 2x squared is 4. 2 times 2, 4. X times x squared. 7 squared, that's 49. So 4x squared minus 49 easily. Then you also have cubes. Okay, should I have Okay, I think I'm good. So cubes of binomials now. So cube of a sum, you have a plus b raised power 3. That's a cube plus 3a squared b plus 3ab squared plus b cube. Then cube of a difference. The only thing that changes is for the second the second and last terms, the signs are different. So you have a cube. Every other expression is the same except for the signs. So for the when you have minus, the signs alternate. Starting from plus, you have minus, then plus, then minus. But for plus, everything is plus all the way. So I think with that trick, you can get that kind of thing. So if you have x minus 2 raised to power 3, so I think I did this under binomial expansion. So you want to check the binomial series playlist. That helps a lot. So you have x minus 2 raised to power 3. So it means you're going to have a here is x and b is minus 2. So you have x raised to power 3 minus 3 into minus 3x raised to power 2 multiplied by 2 plus 3 times x times 2 raised to power 2 minus 2 raised to power 3. And then you expand all that. You have x cubed minus 6x squared plus 2 raised to power 2 is 4 times 3. That's 12x minus 8. And that's done. Then you have the general binomial theorem. That's where that playlist is really very useful. So I went into details to talk about that. So general, a plus b raised to power n is binomial theorem. So the binomial theorem states that you have a plus b raised to power n equals summation from k equals 0 to n of n combination k, a raised to power n minus kb raised to power k, where n combination k is n factorial over k factorial multiplied by n minus k factorial. It is the binomial. So this is the binomial coefficient. N choose k. That's like out of 5, you choose 4, or out of n, you choose k, whatever n is, whatever k is. So each term has coefficients n combination k, and the power of a is always n minus k. The power of b is k. So you discover that when you add the power of a and the power of b together, it gives you n. All right. So the addition of the powers that for any term must be equal to this power n you have right here. So example using binomial theorem now. So you have x raised to power 2 raised to power x plus 4 raised to power 2. Now the reason why I'm not wasting time with this is because I have a playlist on binomial series which you may want to refer to. Maybe I should even navigate to it to show you that particular one. So I just come here now. So I want to leave this place and then take you to my YouTube channel here. So I go here and then so just go to playlists and then find your way to binomial series. I was wearing a green shirt there. Yeah, here. So this is binomial series. I have 15 videos on that, right? I have 15 videos right there. So you want to go through this whole thing, right? So, I mean, I go step by step to talk about the things that really matter in that regard. So you want to check the binomial series uh, playlist out. So that's why I'm not wasting my time here. So expand x plus 2 raised to power 4. So here a is equal to x, b is equal to 2, and n is 4. So if you use to get the coefficient now, so binomial coefficient for a plus b raised to power 4, you have 4 combinations 0. It's a summation, right? You have summation n combination k and all that. So you have 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, 4 combination 4, and you have 1, 4, 6, 4, 1, So of course, you following the law of combination. So x plus 2 raised to power 4 now is 1 times x raised to power 4 plus 4, this 4 now times x raised to power 3 multiplied by 2 plus the next one, 6 x raised to power. So you see the power of x starts from 4 and it keeps dropping, and the power of 2 starts from 0 and it keeps increasing. So 2 raised to power 0 here, 2 raised to power 1 here, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4. So you have 6 x raised to power 2, 2 raised to power 2 plus 4, this 4 here, x raised to power 1, 2 raised to power 3 plus this one, yeah, then x raised to power 0 and 2 raised to power 4. So by the time you compute all that, you have x raised to power 4, 4x cubed times 2, 8x cubed, 6x squared raised to power times 4, 24x squared, 48, 4x times 8, that's 32x, 2 raised to power 4 is 16. By the time you tidy all of that up, you have x raised to power 4, 8x cubed plus 24x squared plus 32x plus 16, and that's what you get. So for more details, check the binomial series playlist. So we have the idea of Pascal's triangle now. So for Pascal's triangle, this gives this is really cool. So Pascal's triangle gives the binomial coefficient for a plus b raised to power n. So rows starting from row 0. So row 0, the coefficient is 1, row 1, 1, 1, row 2, 1, 2, 1, row 3, 1, 3, 3, 1, row 4, 1, 4, 6, 4, 1, row 5, 1, 5, 10, 10, 5, 1, etc. Row. Each interior number is the sum of the two numbers above it. The edges of each row are 1. So row m gives the coefficients in a plus b, raised power n. Now, I mean, don't stress yourself. I know you're already wondering that you don't understand what I'm explaining. So I'm going to take charge of that. So you're talking about a plus b raised power n, right? So for n equals 0, a plus b raised power n, a plus b raised power 0, anything raised power 0 is 1. You already know that. Then for n equals 1, now you have a plus b raised power 1. That's simply 1a plus 1b. So that's why you have 1, 1. And then you have n equals 2. So you have a plus b raised to power 2. That is a squared, 1a squared now, plus 2ab from what we did before, plus b squared from what we did from the other, talking about a plus b squared. So you now see you have 1, 2, 1 as the coefficients now. So you have 1, 2, 1. So, and the whole thing goes on like that. So basically, starting from the first row now, the coefficient is 1. Then next, this one now, write it down twice. 1 comes down, 1 comes down. Next, you now have this one comes 1 times 1 plus 1, 2, and this one comes down. That is for n equals 0. Then this is n equals 1. Now this is n equals 2. At least we know this one from expanding directly. So if you go to n equals 3, what do you have? You have 1, 1 plus 2, 3, 2 plus 1, 3, and then 1. Okay? That's for n equals 3. So for n equals 4, what happens? You have 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and then another 1. Okay? So if you have something, a plus b raised to power 5, okay, what do? 1, 1 plus 4, 5. So 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5, and then 1. And then it goes on like that. Let me try and do 6. So for n equals 6, what happens? 1, 1 plus 5, 6. The second term is usually what the power is, right? So I think I want to mark this out to avoid it overlapping. So 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15 again. Okay, I think I need to shrink this a bit to accommodate 5 plus 1, 6 now. And then we have 1 dropping off that way. Okay, so that's how the Pascal's triangles go. So Pascal's triangle goes rather. So you want to check the binomial series playlist because I also have that properly explained there. So now in this part, I'm talking about polynomial division. So I'm not going to waste time because in the next video, I'm going to talk about polynomial division properly. So, but this is just an introduction to it since we are talking about operations on polynomials. So watch out for the next video where I talk about polynomial division, but I'll just go through this and then there I'll do the real deal. So division algorithm for polynomials. So for polynomials f of x and d of x, where d of x is not equal to 0, there exists unique polynomials q of x and r of x such that f of x is equal to d of x multiplied by q of x plus r of x, where either r of x is equal to 0, r of x is equal to 0, or degree of r of x is less than degree of d of x. I will explain all of that in the next video very properly in case you don't get this. Here, f of x is the dividend, okay? D of x is the divisor, q of x is the quotient, r of x is the remainder. So we find q of x and r of x using polynomial long division. That's the general one. And then we can use synthetic division, special case when dividing by x minus c. So I'm going to talk about all of that in the next video. So polynomial division is the subject of the next video, so watch out for it. So some practice questions right here. So for addition and subtraction, so try to if you want to try your hands on adding and subtracting this polynomial. So you have these expressions added, this one subtracted. So like we did the other time, your minus can go inside. You have minus 2x minus 4x plus 6, and then you operate on them. Same. Then for multiplication, now we did the FOIL method where you just that's the normal one, x times x, x times 2, minus 5 times x, minus 5 times plus 2, or you can do the box thing. So try all of that in all these places. Then you can have special expansions on binomial theorem. So for binomial theorem, you already know this is 2x all squared plus 2 times 2x times 7 plus 7 squared. Same for the next one. And then this one, 4x plus 1, 4x minus 1. That's simply 4x all squared minus 1 all squared. That's 16x squared minus 1. So use binomial expansion, binomial theorem of Pascal's triangle to expand this. This is power 4 now. So the coefficients are simply going to be 1, 4, 6, 4, 1. So you're going to have 5 terms for that. Okay. Yeah. So for this, it's going to be, this is power 5, right? Yeah. So you're going to use 1, 5, 10, 10, 5, 1. So it means you're going to have 6 terms for that expansion. So all of that. But if you still think you need help with that, you want to check the binomial series playlist on my channel, and where everything is broken down properly there. Thank you for listening to this interesting video about operations on polynomials. This is not the end of it, because in the next video I'll be talking about polynomial division, and that will conclude operations on polynomials. So thank you so much for listening. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much. If you haven't subscribed, of course, you don't want to miss out on anything going on. All right. So why not go ahead and subscribe and hit the notification bell, so you can always get alerted each time a new video is released. Having done that, you can click on join to become a member of this channel. All right. Click on join and become a member of the channel. And that comes with some special privileges, like having a one-on-one hangout with me to talk about anything that I talk about on my channel, be it mathematics, data analysis, data science, machine learning, scholarships, whatever. All right. Whether physically or online, if you're in the same physical location at any point in time, if you're a member at a particular level, that is very possible. Okay. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.